All right, so we're right at the top of the hour, 7 o'clock, and we do like to start on time, so we're going to go ahead and jump right in. My name is Don Adju. I am the Program Director for Citizens Climate Lobby, and I want to welcome every one of you to the North Carolina En-ROADS Simulator Workshop. I know that we have a lot of volunteers on tonight, and for our new folks, Citizens Climate Lobby is a nonprofit, nonpartisan organization dedicated to creating the political will for a stable climate. And the only way we get there is with your help. So we are delighted to have you here tonight. Momentum for climate action is growing in Congress, and there's a plethora of policy solutions being discussed in Washington, D.C. Some are more effective than others, and so the question on many lawmakers' minds is what combination gets us to a livable world the fastest? To help answer that question, I have the honor this evening to introduce Andrew Jones, joining us from Asheville, North Carolina. Andrew Jones is the co-founder and co-director of Climate Interactive and a research affiliate at MIT Sloan. An expert in international climate and energy issues, he is a systems dynamic modeler, keynote speaker, and designer of simulation-based learning environments. I had the pleasure of meeting Drew at our Southeast Regional Conference several years ago, and his presentation was spectacular. So I think you all are in for a real treat tonight. And with that, I'll go ahead and turn it over to Drew.
All right, thanks, Don. Thank you, and thanks to the crew that made this happen. Don Kraus and Libby and Steffi, the others on our organizing team here, and here on our team at Climate Interactive, Janet Tchaikovsky, who is another local, another North Carolinian, and just happy to be here to engage with you all. And the headline is, I'm particularly happy to be here because you guys are right. You are right about the power of a carbon price to drive the kind of change that we need on climate. And I want to not just assert that, but I want to bring you on a little bit of a learning journey to show you why I've reached that conclusion, that this is a powerful way to address the climate challenge that we all face. Now, doing that by just saying it isn't as powerful as exploring it yourself. So I'm going to switch over, I'm going to go over to our simulator and show you how we're going to explore this issue. We're going to do it using our simulator called En-ROADS. And Janet, if you just send a link to everybody right now, you can go and play with this yourself. It is open source, freely available. All the equations are published on our website at climateinteractive.org. It's built using the best available science between our team at Climate Interactive with MIT Sloan, and calibrated against the big integrated assessment models that are used to chart out various climate futures with data from the IPCC, the international bodies that pull together climate models. So what we're going to be doing is testing various scenarios here in En-ROADS. And the world that I want to just welcome you to is a world where we don't take strong action. So what you see here isn't going to happen. We're not going to head to 3.6 degrees because amazing people like you are taking action around the world to avert this terrible future. Now, mind you, this is a global model. So think of the US, but the United States emissions is 15% of this. A lot of what I'm going to be talking about is relevant to India, China, Indonesia, Mexico, Brazil, the fast-growing nations, South Africa. And that is where we see the energy future that is likely to the top left here. See the brown area of coal, on top of it is oil, on top of that is natural gas, then we have wind and solar, and biofuels and nuclear. If we burnt all of those fossil fuels and add in from agriculture and other sources, other greenhouse gases, you'd see the pollution in the top right that you see going up and up and up, and temperature an unmanageable 3.6 degrees. And what we're going to do is test it in this model. And you can see I've just made a change, in this case about energy efficiency and transportation, efficient cars. The way it's going to work is that our model runs so fast that you're going to be able to see the result of any change immediately to see what it does to the fuel mix, to greenhouse gas emissions, and therefore temperature, how much it's going to reduce overall emissions. So that's the game that we're going to play. Excuse me, I got to move some of these things. So that's the game. And it's going to be done, but we're not going right at the power of carbon pricing. I'd really like to go around it a bit and first explore, because you're in conversations with people, and we're actually kind of curious to hear the answer to this question. You all are talking to people, and as volunteers, you sit down with that member of Congress. This is lobby week, right? When you sit down with people or with others that you're trying to convince, invariably people have this long list of things other than a carbon price. Which are the ones that you think are the most over promoted? You just hear over and over again, people going on about X, and then you have to steer it back, but carbon pricing. Okay, solar panels, reforestation, grow trees, trillion trees, regulations, tax credits for renewables. Don't we just, all we need is more wind and solar, sequestration, carbon capture sequestration, planting trees, the Green New Deal, reusable straws. Oh no, carbon sequestration. Okay, many types of that. Personal choices. Maybe we just need to recycle, drive less, turn off the lights, subsidies, eating meat. Maybe eating meat is the problem. Planting trees, carbon sequestration, growing trees. Boy, there's a lot on the trees. This is really helpful to see. All solar geoengineering, spray some sulfate aerosols into the stratosphere, lower temperature, electric cars, solar power. So I'm getting a lot on solar renewables, a lot on trees. Fascinating. This is so helpful to see, and a lot on sequestration. What else? Efficient buildings. And I'm just going to cut to the chase a little bit. There's no silver bullet. Even carbon pricing isn't a silver bullet. It's going to require many actions, but some actions are really helpful and some not so much. Let me see if others are coming in. Boy, you're just helping me out. This is great. Do nothing. Someone will figure out something through technology. It'll just save us kind of magically. That's interesting. Okay, this is really great. And you're still, keep on writing them if you like. We're going to now test some of these and get you thinking about actions. So here we are with exploring various futures, and all the futures and the sliders that we can change are here at the bottom. So you see we can change coal, oil, gas. There's carbon pricing. New zero carbon would be actually that's the technology one that was just mentioned. Do nothing. Some magic technology will sort it out. So we imagined, say there was a magic supply of energy that was cheaper than coal that came in, in the next few years. Would it save us? Wind and solar, energy efficiency, sequestration is over here, in carbon removal. So I'm going to pick one of these to start with. And you guys mentioned trillion trees so many times. I think I just got to go there first. So we're going to just put energy aside for a second and say, well, we're putting all this carbon in the atmosphere, but wait, photosynthesis pulls carbon out of the atmosphere. You put it in, let's just take it out. So I'd like you to imagine trillion trees. This would be huge reforestation and afforestation, new trees grown in many places around the world, more of the area of India covered in trees around the world. Actually, it's about the area of the US and China that's the area of 1 trillion trees. So that's what we're going to do. And to do that, and I'll show you along the way, you can change many of the assumptions in the model. To get to 1 trillion trees, I actually have to go under here in the assumptions under afforestation settings and increase it to 900 million hectares. That's 1 trillion trees. By the way, many of the assumptions you can change here. And that's part of our commitment to transparency. So we're going to grow a lot of trees. I want to look here, not at the use of energy, but the power of it would be CO2 removals. And I'm also going to look at it differently here to show negative emissions. So what you see in this graph over on the right is all the land use CO2 from cutting down trees in Indonesia and Brazil. All of this dark area is from burning coal, oil, and gas. Then you have methane and other gases on top. When we remove carbon from afforestation, we're going to see negative emissions. We'll see an area below the zero line pulling carbon out. So if we grew 1 trillion trees, how much do you think it would help? How much would that 3.6 degree temperature come down? How much would it come down? I'm going to ask you quite explicitly here. So what will the temperature be? We grow 1 trillion trees. Will it? Oh, you're getting to it already. So vote. Go ahead and vote. Let's see what you come up with. Oh, it's 3 to 3.3. Some people think under 2 degrees. Maybe it is a silver bullet. We just grow that many trees. It pulls all the carbon out. Boy, there's a lot of span of estimates here. We have people voting below 3 degrees, below 2 degrees, or somewhere in the 3s. But 50% of you say it'll bring us all the way down to 3 to 3.3. That's getting the most votes. Keep voting. Let's see what you think. Keep voting. 45% of you say to 3 to 3.3. All right, it seems to be leveling out. 3 to 3.3 seems to be the winner. Okay, let's go back and test it. So we're going to run it in the model. And the way we do that, and you can do this yourself, I'm just going to crank this up. There's a lot of assumptions under here about what year it starts, how long it takes. It takes 10 years to find the land. But let's go just try it. And are you ready? Here it comes. And there it is. It removes how many? 8 gigatons a year. That is a large amount. 8 gigatons a year gets removed. I'm going to run it again to see what it does. And you can see over on the right, the dark area of energy CO2, the height of it doesn't change. But do you see the positive emissions? The green area turns negative. You see that area below the 0? That little green area is what's getting pulled out. But you notice the huge difference in scale between what's getting pulled out from the trillion trees over time and then what's getting put into the atmosphere from burning coal, oil, and gas. What we have is a false equivalency here going on. People think trillion trees is a big number. It sounds like it's a big deal. However, it is in no way comparable in scale. Well, in no way. It is not significantly comparable to the burning of coal, oil, and gas and all that's going into the atmosphere in that dark area. So temperature only comes down 0.1 degree. So one is just how little gets pulled out, but also notice when. What is the year that it really makes a difference to the atmosphere? You really are pulling carbon out. Well, it takes a while. First, you find the land, plant the trees. Trees grow steadily but slowly. It isn't till the 2050s and 2060s that we're going to see a significant contribution. It's delayed. It's not that much. And therefore, it's a very modest return. Now, maybe we should do it. However, it is relatively small in how much it can help. The other thing that needs to be considered, and you know I'm going to be pressing you on this, is equity considerations. Are we putting in solutions that actually help people? And we're concerned here, land for growing CO2 related biomass. How much land? I said, how many million hectares? It's growing up to about 800. There is the area of India. It's about 2 Indias of land, more than 2. So who lives on that land now who doesn't want to move so that policy people, governments can grow trees because we're still burning coal, oil, and gas? Okay, so this is one of those red herrings that as you engage people and talk about carbon pricing, they're going to bring up. But there's also other people who have written about this, and we have a blog post. Actually, Janet, can you send around the blog post that lays out this whole argument? So don't let the people you talk to divert you too much into this as a solution. Maybe it can help. It takes many seeds to plant the garden of climate success. It takes many actions. This could be one, but it's not a big one. All right, I'm going to pause with this and move on to some of the others because you guys listed a whole lot of other things that may be kind of distracting. I'm going to go back to this main view. Here we are at 3.5. What else? Well, there's this idea of technology and maybe a new energy supply could save us. Why tax carbon now when we could probably wait for some amazing technology to come in and save us? So we simulated that and we actually said, well, what if there was something like thorium fission or zero carbon Zero carbon thorium fission or nuclear fusion is the other approach that could come out of the lab, say in the next 5 years. So in the same way, I'd like you to think, what do you think if we had such a solution? I'll ask you, well, let's do it again. Why not? What do you think if we had zero carbon coming out of the labs next year? I'm going to clear all these responses. Cheaper than coal. It's 20% cheaper than coal is right now. How much? It's super cheap. It's going to spread around the world. By the end of the century, it will be the largest energy supply. What will it get us to? You're voting 3 to 3.3 is the winner again so far, but some people think it's a silver bullet. I mean, why not? Technology saves us. That's just what it does, right? Okay, again, there's a wide spread of guesses about what it would be. Most of you are at 3 to 3.3. And okay, here we are at 3.5. I'm actually gonna, no, let's keep afforestation. We're gonna keep that there. We're growing trees. What else? Maybe this will do it. New zero carbon. Okay, I'm going to run it and all right. You see that orange area growing? That is this new supply. It's the orange area, and I'll show it here. Final energy type, it's new zero carbon energy. That's how it grows. It's growing significantly, much faster than any other supply of energy has ever grown in the history of the world. Faster than coal, oil, gas, faster than uranium type nuclear. It grows a lot. Notice though, when does it help? In what year does it keep coal, oil, or gas in the ground? And mind you, that's what we want new supplies to do. If they're going to help, it's not because we have them. We don't even need wind and solar. For the climate, we need wind and solar to keep coal and gas in the ground. If it doesn't do that, it doesn't help us at all. So what year does it help? Can anyone see? Like, look here, here it is. 2020s, no change. 2030s, no change. It's not till the 2040s that this really kicks in and helps a good bit. And then it doesn't help that much. It only shaves off 0.2. It only shaves off 0.2. That's because we have long-lived infrastructure that lasts 35 years, coal infrastructure and gas infrastructure. And we just keep on hanging on to that infrastructure until we start getting some new zero carbon energy in. Now, what is the other problem? It's delayed, but also, how does it spread around the world? Well, it spreads around the world because it's cheap. Look at what happens to cost of energy. If cost of energy goes down, what happens to energy demand? I got to hear a voice here. Someone unmute on our team. What happens to energy demand? Someone unmute and say, what happens to energy demand if we see that kind of drop in cost of energy?
It goes up.
Yeah, exactly. So energy demand, why would you conserve as much? Why would you turn off the lights? Why would you invest in efficient infrastructure, buildings, insulation, et cetera? You don't as much if energy is cheaper. Now, it's not doubling consumption. It's a modest increase, but that matters. And it's going to really matter in a second when I show you what's so great about carbon pricing. It's going to matter in a second. This feedback effect via demand. Okay, so there it is. We see the two big reasons that there's such a modest improvement that comes from it. So as you can imagine, I'm going to pick up the pace with some of these other ones that I want to show you. There are a whole set of lowish leverage, lower priority actions. Maybe we should do some of them, like a zero carbon energy supply would be great after 2050. They might help then, but there are a whole series of things that are lower priority that don't help that much. I'm not going to show you as much behind each because I want to get to the good news, but I'm going to show you a little bit of the other things that you mentioned. And let's talk about sequestration. So there's coal CCS. So this is where you capture coal at the end of a smokestack, liquefy it, and shove it underground somewhere. And so imagine, and I'm going to imagine how much we might see that in the future. Coal CCS, I'm going to encourage it. So watch this dark area over on the right increase as we make coal CCS cheaper. It doesn't even bring temperature down 1/10 of a degree. Now I'll add gas CCS. I think gas CCS does a little better. And you can imagine on some power plants, it could help a power plant. Oh, brings it down 0.1. Those are two methods of sequestration. There are also 5 other types of carbon removal that are being imagined that we model here. And I'm going to pull up the removals here. We talked about afforestation being one, but there are also 5 other types. I guess I'll call out the folks who said sequestration. Can someone just say what you hear about the most? Somebody just name, is it bioenergy? Is it direct air capture, ag soil carbon, biochar, mineralization? Which one should we try? Which in the sequestration world do you hear about?
Ag soil carbon sequestration.
Yeah, we hear a good bit about that, and we probably should do it. Don't till the soil. It captures more carbon, and let's try it. When we simulate the middle point of what the Royal Society estimated was possible, here it comes when I say 100% of that, and I'm going to increase it. That's adding what? Another 4 gigatons a year, which is a lot. And I'm going to replay it a couple more times. 0.1 degree. So it is a modest improvement. A modest improvement. And just to give you a sense of the scale, I showed you this graph before. Watch, look at that. See the silver band? That is the removals. That is under 0 and is being pulled out. In the same years above the line, do you see the black area? That is burning coal, oil, and gas. So again, there's this equivalency problem of how little is getting taken out, how much is getting added in any year. That's the challenge. And it's not a question of whether we should have farmers do this. They should. But what is the priority? The priority, if you want to get down to 2 degrees, will be doing something to keep coal, oil, and gas in the ground in the next 5, 10, 15 years, 20 years, maybe. Got to keep it in the ground very, very soon. Okay, so these are a couple things. The other one that we often hear about is electric cars. And what's great about electric cars would be that what they do to oil. So watch what happens if we electrify transport. Look at oil. Holy smokes. This really could turn things around. This is a world with 70% of transport electrified. Wow. It really cuts oil. However, look over on the right. What did it do? It shaved, well, an important 0.2 degrees off of temperature. Only 0.2. Why? The same challenge as I mentioned at the start. What year does it keep coal, oil, and gas in the ground? Well, in this case, oil. Look over at the graph. It's in the 2040s. We need to keep it in the ground in the 2020s and the 2030s. It takes a long time to get rid of the internal combustion engines and bring in this new electric vehicles as that industry grows. Secondly, where does the world get new electricity? I think India, think of China. Where does the world get new electricity if there isn't a price on carbon? When we model it, more coal, more coal, more coal. That's one thing that eats into the benefit of electric cars if you don't also decarbonize the grid. Now, more coal, big problems in Beijing and in New Delhi. I've seen both. And what's happening to deaths from PM 2.5 emissions? What's happening to inequality because of environmental injustice? It's more marginalized communities, lower income people who live near the power plants, who have to breathe the air, the PM 2.5 emissions here as you see it goes up. This is a world with worse air quality, not better air quality because of all the coal that's being burned. So I'm kind of coursing through a bunch of the things, and I think I'm just getting myself depressed about all of the other low leverage things that are just lower priority. So I want to bring us back around, and I'm going to undo all of those and come back from scratch and say, okay, let's think about a carbon price. Let's think about a carbon price. And actually, I'm just going to pause before I ask I go to a carbon pricing and what is so powerful about it. Libby, are there any questions that have come up, or Janet, that have come up that you think, wait, Drew, you just went over that car thing too fast, or thorium fission, have I lost? Is there any questions that indicate I've lost people and I can help get people back with some of these perhaps important but lower leverage actions?
I think
Or should we just keep on rolling?
Janet's done a good job of answering questions in the chat.
Good.
One thing that comes up sometimes is conservation, just using less energy. Where's that?
Yeah.
Is it totally hopeless? Someone asks. Where's
Well,
that?
using less energy, I'm going to lump that together with energy efficiency, with turning off the lights, but also with insulation, efficient motors, appliances, lighting, etc. And you'll see, we're going to come back to it in a minute, but you'll see how it complements carbon pricing. And how does it do it? Basically, right now we're improving our energy efficiency about 1.2% a year. That is the new capital, the new things that are being installed around the world are getting more and more efficient, 1.2% a year. If that improves and we do more retrofitting, it could really reduce energy demand. And I'm going to go over to energy demand again. Here it is. It could, instead of having energy demand going up like that, it could actually balance it out. And then we would need less coal, oil, and gas. And it could bring temperature down a full 0.4 degrees. Energy efficiency really matters. And a carbon price does not take the place of it. So these are complementary policies. And I'm going to show you in a minute how a carbon price needs it, because we'll add it on top. So I'm going to go back to where we were before. But before I hit the carbon pricing button, I want to ask you another tough question that I think really matters for you all strategically and for all of us who would love to see carbon pricing in the world. And the question is this: what are the equity considerations? Remember I talked before about afforestation and the challenges of pushing people off the land. I talked about electric vehicles and coal. What are the equity related co-benefits you'd hope to capture from a carbon pricing? We're about to hit, I'm asking about carbon price. What are the equity considerations that concern you about a carbon price, or co-benefits that you hope to capture with a carbon price? So I'd love to see, so think about it, and actually you're writing it. I want to just also pull up, if along the way there are things or questions or things that you see, write on Twitter. Andrew P. Jones, Climate Interact, En-ROADS. Love you if you're people who like Twitter. Here are the handles you can use and the hashtags about this that we really would love you to write about. Hashtag En-ROADS. Let me see what you come up with. Increased costs most affect the poor. Raising prices hurt the poor. Total cost of energy. Absolutely. Lower income people get more money back than paid in. Well, that would be great. That would be the co-benefit, is if that were the case. Additional costs on frontline communities. Co-benefits improved health. So we have health, we have prices and costs. Effect on low income folks. For equity, you need a carbon dividend. Cost of energy. That effectively deters big companies who may not see it as worth it. Cost for the poor. These are great. So we should look at many of these things. Yeah. Reducing pollution helps everyone. So that's a co-benefit. Cost of energy for lower income people. So let's go explore some of those. It could exacerbate environmental racism. We don't want that. Let's go see. So here we are. We're going to put in a carbon price. And then I really, though, want to, actually, let's go straight to the proposal. And you guys are so powerful in the modeling world that we changed our lever here under carbon price because of you asking us to allow it to go all the way up, somewhat like a global version of the carbon fee and dividend bill. And so I'm not going to do it perfectly. Mind you, this is not about the US, this is globally, but I'm going to simulate it. And what I'm going to do is I'm going to first put it up to 15 starting in 2021. And I'm going to make it go up to 15 over 4 years. So it gets up by 2025, it'll be at 15. Then I'm going to go up, what did you guys say? $10 a year. And I'm just going to see what we get with $10 a year. By my math, that means we're going to get all the way to $765 a ton starting in 2025 over 2025 to 2100, which is 75 years. Boom. So look over on the right. There it is. It's at 15 and it goes up 10 a year, up, 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 up. I'm just going to check Don and Libby. Good enough for now? Good enough for now? You like this enough for me to go ahead?
That's a good start there, Drew.
That's a good start. That would be, this would be amazing. And what did it do? 2.6 degrees. 2.6 degrees. Why? Well, before going into the why, I asked you about equity consideration. Well, no, hold the thought about equity. We'll come to that. I want to first show you what it does and why it's powerful. So here we were before looking at coal. And I showed you those pictures of how alternative energy sources, such as that new thorium fission, how that was going to help in the 2040s. The powerful thing about this with the timing is that, look, it kicks in 2023 is when coal starts to go down and down and down and down and down and down and down. What about gas? Natural gas as well. Hold on, let me go down to primary energy types. Natural gas in the 2020s starts going down and down and down. And oil in the same way. All three go significantly reduced and soon. The result is, look at that dark area of energy CO2. Peaks in the 2020s and it shrinks significantly. You remember where we were before, where that dark area was growing and growing and growing. Now it's shrinking and shrinking. This is why it does the amazing job of cutting out in this run a full 1.0 degrees C from 3.6 all the way down to 2.6, which is a huge contribution towards getting us well below 2 degrees. Now, the one thing, and Janet, you and I worked with actually a team at CCL to make sure it was very clear that it's not a silver bullet. There is no silver bullet. There's no one policy that's going to make all of this action happen. Instead, it is a significant contribution. And this result, by the way, is consistent with the modeling that comes out of the integrated assessment models and the ones that create various what are called SSP scenarios. They found the same thing, that you would get this sort of contribution from a high and rising carbon price. Now, I want to talk a little bit more about what else it's going to take, but first I want to go to the equity things that you just wrote about. And you asked about about equity considerations. And so it really comes down to what's happening with prices. And the challenge is that the cost of energy, as you know, would go up. That's the power of it. It's making coal, oil, and gas more expensive. We don't yet have the renewable energy that would be the zero carbon supply that brings the price down. That is what brings the price down in the longer term, but it takes a long time for those sources to get to scale. So initially, you're going to have a boost in carbon prices. So, a boost in the cost of energy. Of course, your answer, as I understand it, in the US is, well, let's look to the possibility of the dividend. And we're calculating as well how much of a dividend there would be. Globally, here is the size of that dividend of that carbon price. It raises in total revenue heading up to $7.4 trillion a year, 8.8 trillion by 2066. So there's a significant amount of money, and I understand the idea would be to have a dividend that gives that money to the people who need it most, or to the people who are paying for it. And I know you've thought a lot about how to make that happen. That said, I agree with you about the concern about what it does to lower income people who need to put gas in the tank, power their houses, and do it around the world. Now, the other equity consideration that's related to this, which is the better news, is, remember what I showed you before about the problem with more coal and air quality? Imagine air quality in this world. Oh, wow. Do you know that 1 in 10 deaths of anybody, all deaths around the world, World Health Organization says, are from air pollution? People are dying, not here in North Carolina quite as much, but people are dying, and particularly in developing countries. That would not be happening if we saw the blue line, if we win on reducing coal emissions and cutting those PM 2.5, which are the small particles that cause cardiovascular disease, emphysema, lung cancer, and other problems. So a huge boost. Now, what I showed you a minute ago when it came to that carbon, to the cost of energy, what is this going to do to energy demand? And imagine in the same way before, remember I showed you about energy getting cheap boosted demand. Look at a second benefit other than changing the fuel mix from a carbon price. And I don't hear Citizen Climate Lobby talking about it as much, but it takes a big cut out of overall energy consumption. Those higher prices do lead people to have an incentive to conserve, to invest in energy efficiency, not just people, but industries as well. Those are some of the reasons that we get all the way down to 2.6 degrees. So I want to just pause for a second and see if there are any questions about this, because what I want to do next is really think about, well, what else do we need to do? It's not a silver bullet. What are the other things that are needed to do to get us well below 2 degrees? So Libby, Janet, any questions just about how we simulated the carbon fee and dividend globally and how what our results are here?
Yeah, 2 questions. One is about the economy, and can En-ROAD simulate the effect of the dividend on the economy?
Well said. The short answer is no. We haven't figured out how to simulate the effect of what would happen with all of the dividend of that money being brought back to people and they could spend it differently. So not yet, but boy, would that be nice, and we're working on it. The other one, Janet?
Yeah, and I'd also point out that you can see that dividend under the financial graphs.
Yeah, we showed it, 8.8 trillion,
Okay.
Love it.
Yeah. And then the other question was about methane, which doesn't seem to be reduced yet.
Yeah, well, hold on. Think about it. Anybody, I'd love to see it. Someone write in chat, would methane be reduced in this scenario? See how much anyone's thought through the effect of a carbon price. What happens to methane with a carbon price? I didn't really think about this until I really modeled it. Curious, someone write in chat, does anyone know? Yes, Evan, because natural gas reductions, right? If we have less natural gas, we have less leakage of methane from the natural gas industry. Look over here, methane and other. See the black line is that because we have less CO2, we modeled the effect of a carbon price on methane. So if people say, oh, carbon price doesn't do anything about methane, yes, it does. Less natural gas production, less leakage. Therefore, look how much it cuts emissions. That is the blue area here, which out in 2100 is the largest source of greenhouse gas emissions. So in this future, we need to be thinking about even more with methane. So great question. Any more that you see, Janet, before we start looking at what else is needed?
No, I think we covered them. Thanks.
Great. So what else is needed? We talked before about how it's not a silver bullet. It gets us very far. It can be complemented by actions in investments and performance standards in energy efficiency in buildings and industry. And one thing that's nice about that, notice what changes a lot? We don't have to build as much renewables. Maybe we don't need as much, which is fine. We don't want to build more wind and solar if we don't need it. Also in transport, what if we have more energy efficiency in transport? Now we're down at 2.5. Other actions such as cutting deforestation, and in Indonesia and in Brazil, 2.4. What if we grew some more trees? This might be a good idea. Maybe not a trillion, but more, 2.3. Maybe some carbon removal. And methane in other, in agriculture, wastewater, landfills, gets us well below 2 degrees. So it's not a silver bullet. It could be complemented with other actions. And when you decarbonize the grid, of course, electrification is one of those things that gets us a little bit lower, now 1.8, and we can get closer to 1.5. So what's the journey I've taken you on? The journey is when you sit down with leaders, with members of Congress, and you're talking about a carbon price, you can explore many of the shiny, attractive things that may be discussed, but many of them are a much lower priority than doing things that keep coal, oil, and gas in the ground. And the main reasons that those other things don't help is that it takes a long time for them to help, or they actually don't remove that much carbon or reduce that much emissions. That said, we need this to work in complement with many other policies. You guys, the carbon price is not the only thing that needs to win. So to Citizen Climate Lobby, please work with your brothers and sisters who are working on energy efficiency, electrification, renewables, reducing deforestation, planting trees, agriculture. Many of these other movements will need to win with you. They will need to win with you. Why does a carbon price help so much? Keeps coal, oil, and gas in the ground in the next 5, 10, 15 years. It also creates an incentive to use our energy much more efficiently and conserve our energy. And it helps in that second way. And we need to watch out for equity considerations. We need to watch out that we don't create more environmental injustice by dumping these costs onto more marginalized communities and lower income communities. And we also need to make sure that we capture the co-benefits, such as better air quality, shutting down coal so our air gets cleaner and people are actually healthier. There's no silver bullet. There are many actions that all together that can do it. It's all about keeping coal, oil, and gas in the ground in the next 20 years, and it's still possible. So I really want the world to win, and these kind of policies, and a carbon price could be a powerful way to make it happen. So I'm going to pause, see if there are any questions about this and any discussion, and hopefully I didn't blow through the hour. Oh no, we still have some time. So happy to see what time it is. So please, what are some other questions or comments about this? Maybe I'll turn it over to the Dons and Libby and Steffi. You've heard me talk about these. Hopefully the message has changed and evolved a little bit more. Maybe the four of you, any reflections that you all have? Yeah, let's put your cameras on. We don't need to just look at my screen. Maybe that's a good place to go. What are your reflections about what I just said, and what seems relevant to you all and to your volunteers as they digest this message?
I just want to say thank you, Drew, so much for doing this. And we totally agree that carbon fee and dividend is not a silver bullet. We say that all the time. We do support other bills now or during our supporting asks as well, and we'll continue to do so, but we feel carbon pricing needs to get done first and then add on more and more and more, for sure. My question to you, or Don, you want to clarify that?
No, I asked you a question. I was going to ask one that Aaron had as well in the chat.
Yeah, if you could just give us some guidance on the impact of regulations, how effective it is and or costly or less costly it is as compared to carbon pricing. Do you have any guidance on that?
Say more about regulations, because there are lots of different regulations. Which ones do you think you're speaking about?
Well, like for example, I don't know, I mean, Clean Power Plan, I don't know how we can compare because it never went into effect, but from what we're hearing, you know, that a carbon price is, I don't know, I've heard anywhere from 10 to 30 times more effective than regulations on CO2, and then it's less costly, whereas regulations is more costly. Is that something you know about?
Yeah, so I'm gonna not get rid of this scenario that we just made. I'm gonna make a new one. And the truth of it is that our simulator doesn't shed much light about which is the cheaper way to go about this. We can simulate taxes on coal and taxes on oil and taxes on natural gas that carve out a lot of emissions into the future. You can also have regulation that mandates energy efficiency in buildings and industry and transport that bring things down a lot, and regulations that require, renewable energy credits, et cetera, to promote renewables. These are things that can do many of the things that a carbon price could do because it keeps coal, oil, and gas in the ground in the next 15, 20 years. So I have to say, this is more of a political question than a engineering and modeling question that I can really address. So I'm mostly going to pass on that and let this more get worked out in the political wranglings that make it possible to go one way or another.
So Drew, Aaron had a question. Has the model been correct in predicting the status quo of renewables? He's heard that renewables are growing much faster than predicted.
Oh my gosh, is that true? And so the short version is yes and no. And the yes is we've captured much of the growth of renewables, but not all of it. And so here's what our baseline was, the 2018 version of the model. And I gave you guys a presentation. I remember talking about giving a speech to your national group back then. Here's what we had renewable energy doing in exajoules a year, 2000 out to 2100. We recalibrated the model just a couple months ago based on these trends that we've been seeing, and look how much faster we think they're growing now. So were we correctly predicting? Not really. Do we correct things when we see a problem? Yes. And this is the data of what we have seen those prices of solar and the prices of wind to do. So we imagine much more already happening into the future and more than we thought, but hopefully we've caught up because we recalibrated the model.
Drew, we have a really good question from Ken Brame, Sierra Club. The petroleum industry just
Ken Brame here in Nashville. Hey, Ken.
Yeah. He just the petroleum industry API just announced their support for a price on carbon. Why shouldn't we be suspicious that this is the answer?
Hold on a second. I realized I wasn't even sharing. I thought I was showing you all these slides. Did I not show you those slides in a second ago?
We saw some, I thought.
Okay, you saw them already. Okay, then say Ken's question again because I missed it.
Yeah, so the API, the petroleum industry lobby, just announced they support a price on carbon. And he's, like many people, why shouldn't we be suspicious that this is the answer?
Great question. So the question to ask is how much of a price on carbon? My understanding is that there have been deals that have been tried to be made between the fossil fuel industry and governments of the world to accept a price on carbon that would be very, very modest and below the price that really puts a dent into their profits. So I would ask how much, and then I would want to use the simulator to say, does it do much? And if we only go up to, I think, $20 a ton or even $40 a ton, and imagine that that's all we're going to do, it is going to reduce coal. I don't think it does, particularly oil industry, I think can support a price of 40 because they look at that and then they see, look at that blue line. Like that is not a big dent in oil. They can say, oh yeah, if in the 2040s, it's going to be a little bit lower, maybe we give in to $40 a ton and get some good support from the world and pats on the back, but we don't lose as much revenues and we only make a modest dent in warming, only cutting out 0.3 degrees.
Could I add to your answer there?
Sure.
We know that some oil companies already have a shadow carbon price of around 60 to 80 or even more by now. And Some are calling for a revenue neutral solution. ExxonMobil has in the past, not all. So that is something to take consideration. Do they really care about whether the money goes back? But also, the main thing as to why these energy companies are supporting a price on carbon is for the predictability that it gives to their business. They need predictability in order to move and remain a viable, successful business. They will transition, but they only transition if they know that they will be successful at that transition. And if they see the price of carbon go up, they will move to another form of energy. So we're just essentially making this happen faster instead of waiting for them to do it on their own volition, or own ethics.
Great, thank
It's
you.
about business.
So other questions or comments from the team?
Evan Parker said, can we model those prices? The 60 to 80 per ton. Oh,
So here we were at 40 and 60 to 80, go up to 80 and you get more of a decrease and sooner on oil, 3.1 degrees. That is a much better world, but it doesn't get you all that you saw with the full carbon fee and dividend plan rising throughout the century.
okay. Yeah, Evan, we did do the one for the Energy Innovation Carbon Dividend Act somewhat. He already showed that for the whole world at one point. And then someone asked if there's what is a shadow carbon price? That's essentially what businesses put into their budget projections in order to model if they would be successful or viable as a business if there was a price on carbon around the world.
Well said. Other questions or comments from our team?
Bruce had a
Yeah.
really good question. Bruce had a great question. Will it take more fossil fuel energy for materials and manufacturing of solar and wind devices than devices saved before they reach the end of their life?
Yeah, so as we've understood the kind of energy balance or energy budget on wind and solar is that contrary to some things that you'll read in the media, they actually do they save a lot more energy than it takes to produce them. So they are net contributors to addressing global warming that way. So yes, very quickly they make up the amount of energy it takes to produce them, and they can help into the future. Other questions that you see, Don? Or comments from you and Libby and Don?
Yeah, somebody's asking for some examples of how En-ROADS is being used, like where and.
Yeah. Yeah, what a good question. So we're using this in two ways. One of them is with members of Congress and with political leaders who are trying to understand what are the policies that will work the best. So largely through our team at MIT Sloan, we're working with members of Congress in different ways. I was invited to give some talks to various groups of Democrats, but also some bipartisan groups out at the Aspen Institute several years ago. So we find, and we hope that you would find, that similarly, it's very helpful as a way to engage other people. So one of the big ways that we're using this is giving the simulator away to leaders like yourselves. So our hope is that you could learn to do some version of what I just did, which was to sit down with a group of people. It could be one person, it could be several of the, a member of Congress, and you would start here with a blank slate and you would say, okay, what are the kinds of things that you think about when you address climate change? And not just tell them that a carbon fee and dividend is the only way, but have them explore for themselves. I don't know, maybe they love nuclear and they get to see the modest contribution that nuclear makes. Maybe they're really excited about, I don't know, whatever it is. They think that they can change population somehow, and that's the only thing that would really affect things. So we hope that you could use this. And the way you would is you would learn more about it by going to our website. And already there, you could call upon members of Citizen Climate Lobby who have become what we call En-ROADS Climate Ambassadors. So here on this page, we have, I'm going to look up En-ROADS Climate Ambassadors, a whole group of 250 plus people who have learned how to engage others by taking our 8-part training course that Janet and I put together with our team. These are some of the people around the world who have taken the whole course. Down here at the bottom, I hope you recognize some of these names. Don, you did this. You're on this list, aren't you?
Mhm.
Is that right? Have you gone through this?
No, I have not.
You haven't.
No.
Okay. Who did I see on this?
Our North Carolina state coordinator, Ellen, has.
Oh,
One
great.
of our Tennessee state coordinators, Jan Berry, has.
Yeah.
We have a bunch.
Yeah. So you guys of organizational membership of anywhere around the world, we have the largest membership from Citizen Climate Lobby. So here's some of the people that could join you and support you in using the model, or you can go to the training part of the model and go learn yourself how to do this. And what it is under training, we have a whole training series of videos that teach you how to do it. Watch the videos, learn how to talk about the various factors in the model, etc. Learn advanced facilitation tips, all of that. So the second way that it's being used is giving it away to people like you around the world to engage other people. And we have a map here that shows all the places around the world that it's being used. So use it yourself and engage other people with a different approach. And you'll note what we're trying to do is help people think on their own terms. And it comes out of this idea that research shows that showing people research doesn't work. For years, we've been writing papers that say, a carbon price is really great. A carbon price is really great. People read the papers, but somehow it hasn't stuck yet. We find that the best way to get around that is to accept that research shows that showing people research doesn't work, and let them think on their own terms. Sit with them patiently and with a simulator like En-ROADS and test the things that would help, have them see both the power of carbon fee and dividend, as well as the modest effect of many other things, but also how carbon fee and dividend needs other policies to complement it in order to get us what we really want.
Hey, Drew. Someone asked, what are you doing with John Kerry? And another asked if you will show this to Bill Gates, please.
So what are we doing with John Kerry? So with John Kerry, hold on. We showed it to him. So we had a really great session. I wasn't there for this one. My colleague, Lori Siegel and John Sturman were there. And I'm going to pull up because I swear I've got something that has a quote here. So right before the pandemic, we had an hour and a half with John Kerry, and he said, it is quite simply a climate crisis game changer for policymakers. It is the ultimate conversation starter. So he gets how you can engage in conversation across different paradigms and views, particularly with people who are much more conservative. The model doesn't just come out and shut people down for being Republicans. It welcomes everybody to think together. Kerry gets that. One reason he gets that is that in 2009 in the Copenhagen Conference on negotiating climate, and then in Paris in 2015, his State Department team, first as a senator, and then his State Department team used our other simulation, C-ROADS, in order to broker a US-China bilateral agreement in 2014 that helped set up Paris. So he had his team, John Holdren, Jonathan Pershing, and others, used analysis from our models in this kind of open, transparent way to get a result. So we have high hopes that he's going to be able to use En-ROADS in order to make a big difference, because this is our shot. Other questions and comments?
Well, Drew, we are at the top of the hour here. So I really just wanted to take a minute just to thank you.
Oh, thank you. Yeah.
Sure. And thank you for the work that you've done in terms of creating these tools and creating this En-ROADS tool and bringing it to the world. And we're just really so proud to have a fellow Ashevillean and a North Carolinian having such an outsized role in climate solutions. So we're really pleased and thankful, and grateful that you're
All
here.
right.
I hope you
Well-
get to teach Bill Gates.
Yeah, he's a big fan of thorium fission and a lot of those solutions. Yeah, and do write on Twitter, tell other people about how they should use En-ROADS, and here's some of the hashtags. Visit us at support and all the materials there at climateinteractive.org. And I guess, yeah, Janet, if you could post any of the, maybe you did already, the trainings. Really hope you can use this simulator to make a difference. Hope you can use it out there in the world. It's not going to be easy. It's going to be worth it. Go get them.
And folks, we'll be sending out a recording of this workshops to you via email, a link to it, so you'll be able to download it and share it with folks. It'll be up on the Asheville CCL Facebook page, maybe on the National CCL YouTube page. We'll see about that, but we'll definitely get it out. We're so thankful that you came and joined us here tonight. So we'll keep the conversation going. If you are not yet involved with Citizens Climate Lobby, citizensclimatelobby.org, it's in the chat. Oh, and if you don't know how to save the chat and all the great links that are in it, at the bottom of the chat on the three little dots on the right-hand side, click on that and go to where it says Save Chat. You can save all this information and you'll have it, and you'll have all these links. So
and you can write any remaining questions to support at climateinteractive.org. That is in the chat as well. I saw a really good one about, if this has been peer reviewed model and all that. So that's something that you definitely can write, Drew. I know he's done a lot of work over the years. Thank you.
Thank you all. You take care. Have a great rest of the evening and enjoy the rest of your St. Patty's Day. Bye-bye.